I'm Mike Sadlowski, and I'm the Columbia Public Schools Science Coordinator. We're going to be doing a weekly science show for you that will range in topics from any number of things, but because it's Halloween week, we're going to do something that is Halloween related. And so I have some demos for you. Then we're going to have some science news. We have some other special guests. And every week we'll have something different for you. The first one that I'm going to do, and all these, by the way, you can mostly do at home with all this stuff we have, and I'll try to explain that. The first one we have is called Grow a Ghost. So all you got to do is take a jar. You're going to draw a little ghost face on it, and you're going to put it in a pie tin. You don't have to put it in a pie tin, but if you don't want to clean up as much mess, we're going to put it in a pie tin. So we're going to get this a little closer to you so you can see it. In the jar, I'm going to put just about a 1/4 inch of soap. Any kind of dish soap is fine. I picked orange because it's Halloween. It absolutely does not have to be orange, and it won't make any difference if it's orange. So I put about, probably a little more than a 1/4 inch, but you need about a 1/4 inch. And next, we're going to put 1 cup of hydrogen peroxide. This is just the hydrogen peroxide from Walmart. 3%. Don't get anything stronger, but at Walmart, that's all they sell. And I'm going to pour the hydrogen peroxide on top of the soap mixture. Let that sit for just a second. And then about 5 minutes ago, straighten this ghost out. About 5 minutes ago, I took 4 tablespoons of warm water and I put a 1/2 packet of yeast in. If you don't have packets of yeast and you just have bulk yeast, about a teaspoon of yeast is perfect. And then give it about 3 to 5 minutes to really start producing the gases. Don't make it hot water, just warm water out of the faucet is what you need. All right, ready? Watch carefully. And you know what? For the sake of this show, we're going to take the pie tin away. I can clean up later. You may not want to do that. And so now we're going to pour the yeast mixture right on top of the soap and the hydrogen peroxide, and let's see if we can produce a ghost. Ready? 3, 2, 1. Let's see what happens here. There we go, starting to produce a ghost. It's still reacting. Still reacting. Let's see how far it goes. As you can see, this one's very safe. It could still produce a mess because it's still rising, but I did try to pick a big jar. If you're close to me, I'm actually smelling like baked bread because this is a yeast. And so there we go. We have now produced our ghost, and let's see if we can produce some hair for our ghost. Here it comes. There we go. So we got some hair for our ghost, and we'll let that just sit for a second while I move some things out of the way and get ready for the next one. There we go. That's a great ghost. And now it's going to cover its eyes and it's going to keep going. Depending on how warm your water is and things like that, how warm your hydrogen peroxide is, it will react either faster or slower. I'd say this is a medium one. So we'll just let that go. I'll clean that up in a little bit. Let me get rid of my stuff. My helpers have some of my other ingredients here that are supplies that I need for the other ones. Okay, this one, I'm going to go over to this guy, the skeleton. So this one you need a jar. So I'll move the ghost in a minute. You need a jar. It can be a regular jar, a spaghetti type jar. It can be anything, but it does need to have either a lid or something that is smaller at the top. And I'll show you why in a second. Next, you need to either have a bubble solution that you bought at the store, or I just made mine. To make your own bubble solution, you're going to just use some water, a pretty good amount of dish soap. I used the same dish soap I had. And then you're going to use put in a little cooking oil. The cooking oil is going to make the soap a little bit stronger. Okay, I'm going to go ahead and move Mr. Ghost for a little bit, and I'll try to put him maybe so you can still see him react, but I put him right there. All right, the next thing you're going to have to make a little something. You need any kind of tube attached to a funnel. This is what's going to make our bubbles. So I'm going to test my bubble solution first. And what I've been finding is it sits here, up there's a little bit. I'm just going to test it. Definitely it's forming a bubble. There we go, perfect, perfect. All right, now what I'm gonna do is I need to make this seal on top of here, and it could just be that I even hold it, but I have some tape if I need to. But I need to produce a gas in there. So I'm making something called ghost bubbles. And to make ghost bubbles, we're gonna take some specks of dry ice. And we're gonna, by the way, on dry ice, if you take metal tongs, it vibrates a lot. And so, you can hear that? It's vibrating. There we go. Hear that noise? All right. I'm going to use a different one because I just put that in the soap mixture. And I'm just going to put some dry ice in the bottle. If dry ice, you can get at Hy-Vee. You probably know this, but a little bit of caution is do not touch the dry ice. It is extremely cold, and it actually will frostbite and freeze your skin extremely fast. I'm just kind of spilling it all over, and that's okay. We'll get it later. Now, dry ice won't do anything. It won't make gas, much gas, unless you have some water. So I'm going to make some, it'll make carbon dioxide gas. All right, we're going to see if that's enough there. And get these little specks here. Let's do one more. Really wanted to make sure it works. That's a good one. Okay. All right, now we're gonna get some warm water, and we're just gonna pour some warm water in, and we're gonna make our gas. And let's see if we can now make what's called ghost bubbles. So I'm gonna see if I don't have to hold this. Tape it, and we're gonna seal it like that. All right, okay, I think we're good. Let's see what we got here. Nice. And now we are making ghost bubbles. Let's see. Now the hard part is to see if you have a good enough solution to actually, there we go. Perfect. Here comes another one. And all it is there's a ghost inside, obviously, but it's actually carbon dioxide inside bubbles. And that one fell. And you notice that was not a lot of dry ice. So when you go to Hy-Vee, dry ice is $1.89 a pound. Get the smallest one, unless you just want to play with it. Get the smallest one you can, and you can save some money. Let's get a little more. And there we go. There are your ghost bubbles. Very simple, a couple dollars. And that's a good time to end it. That came right off there. As you can see, there's the gas that's coming out of the jar. Carbon dioxide gas, because dry ice is simply frozen carbon dioxide. All right, we'll put this over here. Now, you could do that one too, and there's two more quick ones that you can actually do, and it takes a little time. And I'm going to be honest with you. I read about this one, and I've never done it before. So I'm going to pour a little bit of this in here to even them out. I have glow sticks. So if you have two glow sticks, glow necklaces, anything, this is a good experiment that you can try. And just in science, I decided I could have tried it first, but I have two glow sticks, and so I didn't want to ruin it. So this may or may not work. But what I have here, and that's part of science, I have a cup of pretty warm water. I microwaved, and then I have water right out of the sink. If you know anything about chemistry, chemistry says that the hotter a solution is, the more energy it has. So in theory, when I break these, and I put one in the cold water, and matter of fact, let's really make it cold. I'm going to go ahead and dry ice it. So yeah, it's going to have a little foam, but really all I'm doing is really chilling that water off. And we're going to see if there's any difference here at all, okay? So I'm going to go ahead and break them. Maybe. There we go. When your hands have soap on them, it's a little, there we go. It's a little hard. Okay. So what do you think is going to happen? What I think is going to happen is the hot one is going to go much brighter, and the cold one is going to not be as bright. Another thing that could happen that I won't keep you on video for, this is something you could try. If that doesn't happen, it could be that the hot one will actually go away quicker because it used up its energy, where the cold one is not noticeably duller, but it was dull enough, and you actually then cannot, it'll last longer, but duller. All right, let's try. Ready? Same time. All right, let's just give it a minute and see what happens. Matter of fact, let me set the next one up. We'll just put this over here, and we'll look at it in just a minute. And I see my dry ice over there starting to, I really want that. Oh, no, it has plenty still. Okay, the last one, this is one that we're going to check on next week for you. So I have 2 cups, any kind of plastic glass cups, jars work fine. This one here is pure tap water. This one has a pretty good amount of salt in it. You want to put enough salt in it that the salt actually stops dissolving. And what you're going to do next is I have 2 gummy snakes. It could gummy snakes because it is Halloween. It could be gummy worms, that's kind of Halloween-like. Or you can use gummy bears if you want. Not as Halloween, but it'll do the same thing. What I'd like you to do, and you're not going to get the answer today, what I'd like you to do is predict. When I put 1 gummy snake in the pure water and 1 in the salt water, and I leave it till tomorrow, what's going to happen? If you happen to have one of those kitchen scales at home, it would be really cool, and you could really tell a difference, to go ahead and weigh it, find the mass of each gummy snake or bear or worm or whatever you use, and then do the same thing tomorrow. But you're not even going to need a scale. You're going to see what's happening. So I put 1 in the water, I put 1 in the salt water. It's not going to do anything magnificent, but we're going to just wait, and we're going to put that to the side. All right, let's look at our last, and we're going to come back to this. Next week's show, we're going to come back and show you pictures of what happened, and then I'd like to know from you. If you guys have them, give your teachers the pictures, let them send them to us. All right, if I am not mistaken, and I don't know if you can tell in the camera, but my 2 kids are behind the camera. Just nod. Can you tell a difference? I definitely can tell a difference here. And I'm going to put it closer, and the camera picks up dull light. But when you do this at home, and again, it can be a necklace, the one in the hot water is significantly brighter than the one in the cold. And I can see from the camera, you can't tell that much because it's really just brightening that dull one. But this one here, I'd say it's twice as bright as this one here. And we're going to let it go. And as it gets colder and colder, it'll probably get duller and duller. But this one will probably last all day long, double the time of this one. All right, again, I'm Mike Sadlowski, and I will be on the show every week. And we hope you enjoy the rest of the show, and we hope you have a safe and fun Halloween. Have a great week.
All right. Hi, everyone. My name is Allie Pigg. I went to Columbia Public Schools, and I'm now a student at the University of Missouri. I'm working with Mr. Sadlowski this year to bring you guys some awesome science shows. And today I get to talk to you about some fun things related to Halloween and the other big thing happening this week, snow. It snowed. So it snowed on Monday, which is kind of crazy. You guys probably thought it was kind of weird to see the colorful leaves everywhere with snow on them. I thought that was kind of weird personally. That's because we aren't super used to it snowing in October here in Columbia. So let's kind of talk about how common it is to see snowfall on Halloween, or at least the week of Halloween. So we're going to look at the climatology of October 31st. So climatology uses a bunch of data from lots and lots of different years in the past, and it finds the average of all that data, which then is sometimes used to predict the weather for any given day of the year. So you're probably thinking, that's not always super accurate, and it's really not, especially because we live here in Missouri, where the weather is always changing on us. But sometimes climatology is still kind of fun to look back on because we can really kind of see how substantial it is that we got snow this week, for example, in relation to how often we've gotten this kind of weather in the past. So on average, the Halloween high temperature is about 62 degrees Fahrenheit, and the Halloween low temperature is about 42 degrees Fahrenheit. That's a little bit chilly, probably jacket weather, but it's not quite cold enough for snowfall. Climatology also says that there's about a 3% chance of us seeing snowfall each year on Halloween. So that's not really a lot. So that means that on any given year, it's not super likely that it's going to snow on Halloween. But you know, here in Missouri, we like to defy the odds. And if you remember last year in 2019, the first snow of the season was actually on Halloween. And of course, this year we saw snow before Halloween. And although we are expecting a warm up for this weekend with a 0% chance of snow on Saturday for Halloween, Monday's snowfall was still pretty significant when you look at climatology. So the earliest snow that has ever fallen in Columbia was on October 23rd, 1917. So that was a really long time ago. And that means that Monday's snowfall on October 26th, 2020, was just 3 days shy of setting a new record. So we were pretty close, but not quite there. So that's pretty cool. So going into this weekend, like I said, we're expecting a warm up this weekend with our high and low temperatures actually pretty close to our average for Halloween on Saturday. And there's no precipitation expected, thank goodness, after the week that we've had. So it should be a great weekend for those trick-or-treaters to get out, or just for people who are eager to get outside after this nasty week of weather that we've had. So don't forget to wear a mask, grab a jacket, because it is going to be a little bit chilly at some points, and set your clocks back before going to bed on Saturday because daylight savings time is ending. So thanks, guys.
Hi, everyone. My name is Liz Kalanda, and I am a student here at the wonderful University of Missouri. In this Halloween week, I want to share with you something quite spooky that I learned from Mike Sidlowski on spiders and natural selection. So did you know that killing spiders around your house makes room for the better spiders to build a stronger army? The spiders that are bad at hiding are the ones that get squashed. The spiders that are good at hiding, on the other hand, are the ones that survive to reproduce and reproduce and reproduce until they take over the world. Okay, just kidding about that world domination part. But it is true that the spiders that are good at hiding are the ones that live long enough to pass on those traits to their progeny. So when you're killing the dumb spiders, you're really just helping the bad guys. So what's the science behind this? The science is natural selection. And according to National Geographic, natural selection is the process through which living organisms adapt and change. Individuals in a population are naturally variable, meaning they are all different in some ways. This variation means that some individuals have traits better suited to the environment than others. So next time you think about smashing those creepy crawlies, you might want to think twice.
All right, the other fun thing I get to talk to you guys about today is goosebumps, and not these kind of goosebumps, which you should all take the time to read some stories from on this Halloween week, but these kind of goosebumps, those bumps that you get on your arms or your legs when you're cold or when you're scared, or even when you hear a touching story. So here's the basic science behind goosebumps. All the hairs on your arms and legs are attached to these itty bitty muscles, as you can see here in red. Usually those muscles chill in a relaxed state, as shown over here on the left, and the hairs that are attached to it are just chilling on your skin, just like they probably are right now. But when you're cold, scared, excited, or you hear that touching story, those itty bitty muscles squeeze up really, really tight into a tense state, as you can see right here, and they pull that hair they're attached to with it. And that causes the hair to stand straight up like this, which is why you get goosebumps. So that explains how we get goosebumps, but why do we get goosebumps? What makes those itty bitty muscles contract and squeeze up so tight? Well, when we get scared or excited, our bodies release this stress hormone called adrenaline, which causes those tiny muscles to contract, and that's what gives us goosebumps. Adrenaline isn't only responsible for making the hairs on our arms and legs stand up straight, but it's also responsible for giving us lots of energy to do fun, active, crazy things, and it also keeps us safe when we're in danger. For example, our bodies release adrenaline when we have to run really fast from a bear that's attacking us, for an example. So here's some other examples of adrenaline at work.
They're all on sides because of that.
Oh! Boo!
Hi everyone, this is Megan Stolting from the CPS Planetarium. On Halloween night, October 31st, 2020, there will be a blue moon. In astronomy, a blue moon has two definitions. It's the third full moon in an astronomical season with 4 full moons, called a seasonal blue moon, or it's the second full moon in one calendar month, called a monthly blue moon. The lunar cycle is about 29 days long, so approximately every 2.5 years, we get 2 full moons in 1 month. Because of this, sometimes we use the phrase once in a blue moon to describe something that happens rarely. On Halloween, this blue moon will be a monthly blue moon, meaning October 2020 has 2 full moons. One was on October 1st, 2020, and the second will be on Halloween night on October 31st, 2020. Blue moons are not really blue. This name originated from writings in the Maine Farmer's Almanac in the early 1900s, calling the third full moon in a season with 4 full moons a blue moon. Some historians think that the word blue in the phrase blue moon possibly came from either French or Czech languages. The phrase and meaning stuck until about 1946 when an amateur astronomer named James High Pruitt wrote an article in the popular astronomy magazine Sky and Telescope misinterpreting the original Farmer's Almanac meaning. This article falsely defined a blue moon to mean 2 full moons in 1 calendar month. This new definition was cited in many places, such as the popular NPR science radio show Stardate, which debuted in 1978, and even in the 1986 version of the board game Trivial Pursuit. Because of this mistake, we now have 2 astronomical definitions for the term blue moon.